Okay, I don't believe that you have this part right here, but this is what this section's about. We're going to do the derivative of e to the x, a to the x, where a is just a number, the natural log of x, and a log some other base than e. And honestly, the focus of the exam is going to be on e to the x and the log of x. You're going to see lots and lots of those types of problems. And I remember last year, students walking out of the exam saying, oh, there were so many e to the x's. So I'm just warning you right now. What is e? 2.7 something. Okay. We're going to start with finding the derivative of e to the x. First, we're going to sketch the graph and then estimate what the derivative might look like. Then we're going to use the definition. And I'm sorry, the slides are just a little bit messed up, but we'll get there. Okay, so first I'm going to draw the graph of e to the x. Now we need to know what this looks like. First off, e to the x is an exponential function. Okay? So what do exponential functions look like? Dylan, what do exponential functions look like? They look like this. And they all go through this point, which is what? Is what? 0, 1. Now, if you were to estimate the slope as you move around the curve, the slope over here is pretty close to 0, but not 0. So it might be that point right there. And you can see it still stays pretty close to 0. The slope here is about 1, if I did a good picture. And now the slope keeps increasing. So guess what? The derivative of e to the x is the same function back again. It's e to the x. Like a phoenix rising out of the ashes. That's right. Harry Potter. So, the derivative with respect to x of e to the x is e to the x. So, of course, you know they're not going to give you questions, what's the derivative of e to the x? It's going to be in the products rule, there's going to be chain rule, because that would be way too easy. Now, do you remember, Grant, the definition of a derivative? Just because I can see it visually doesn't mean I necessarily believe it. So let's go ahead and look at it. It's the limit as h goes to 0 f of x plus h. I could do c plus h all over h. Now, you don't have to do this proof. I'm just showing you this proof because I think it's kind of interesting. Remember, f of x is e to the x.
So is it x times x minus 1?
No, it's an exponential. It's e to the x plus h minus e to the x all over h. You're not going to have to prove it. I'm not going to use the definition. I'll summarize it all at the end, what you need to know. Okay, and I don't know what to do with that, but I do know some properties of exponents. I can write e to the x plus h was e to the x times e to the h. Because you remember what you do with the exponents? When you multiply? You add them. So I'm going this direction. Okay, so it's the limit as h goes to 0 of e to the x times e to the h, the only thing I can think of to do, minus e to the x all over h. What do you think you can do now? Factor it. So I'm going to take out e to the x. Is that okay? So it's the limit. When you don't understand something, or if I go too fast, you need to let me know. Because I feel like I'm really slow. It's e to the x times e to the h minus 1 all over h. Now, when you take the limit as h goes to 0, does that affect e to the x? There's no h's in e to the x, is there? Are there? Now let's pull that out. So that's the same as this. And then I'm stuck. then I'm going to have to use my graphing calculator to find this limit. Because h doesn't affect e to the x. X is not a function of h. So that's another little aha moment, which is kind of nice. I'd like to find that limit. Now, h going to 0, x going to 0, these are dummy variables. So I'm going to put this on my graphing calculator. But on my graphing calculator, because I don't want to type in h and I don't want to change my axes to h or whatever, I'm going to actually put in y1 is equal to the e to the x minus 1 over x. And now look at what happens when x equals 0. And since I have my calculator already here, and there it is. So y equals, you're going to have to put in parentheses. And then I have my axes off, so second format, I'm going to turn my axes back on. And I'm just going to zoom at 4. And I want to know what happens when x gets close to 0. Remember, not at 0, but close to 0. What does it look like it's getting close to? 1. If I do a trace, oops, I'm going the wrong way. 1, 1, 0. See, there's nothing there. If I turn the axes off, let's see if we can see that hole. Second format, that's the reason why they were off from the other class. Enter. You could see just a tiny, tiny break. Not much. So it looks like it's getting close to 1. I can see it actually better in the table. If I go under second table set and I start at 0, by changing my tables really small, I'm going to go second, calculate. I can't prove it, but it sure looks like it's 1, doesn't it? So that's all there is. Whoops, that's a little big. There we go. Okay, so this is 1. And this was the derivative with respect to x of e to the x is, guess what? E to the x. So hopefully you believe it a little bit better. You're just going to memorize it. Okay, so the derivative of e to the x is itself. Now, I don't know why my slide is on the next page, but yours is still on the same page. So what if I have the chain rule? What if I have y equals e to the f of x? Let's cross that out. Then what's y prime? Okay, ready? Ask. Okay, so the derivative of this is e to the f of x back again times the derivative of the inside function. I know it doesn't look like an inside function, but it is. It's a composite function. You're going to do f of x and then raise e to the f of x power. So it's times f prime of x. That's all there is. So I'll rewrite this so we can read it. Too little. So the homework problems shouldn't be too bad for the first day. Well, you get to the base logs, that gets trickier. But what's y prime here? Oh, am I on the next sheet? I think I am. Yeah, if you turn the page, let's find that derivative. What is that derivative? Grant? What do you think? It's e to the same thing back again. Not e to the x, it's e to the x plus x squared times the derivative of x plus x squared. Yeah, 1 plus 2x. I think there's much of it. I can't scroll, that's it. Yeah. So you do the derivative of e to some function of x, you get that same function back times the derivative of the inside function. Chain rule. Chain rule. So some people ask, well, will the test include the first part of chapter 3? Yes. Because that's the product rule and the quotient rule. I can't separate those things. Is that okay? Now, e to the x is an exponential. 2 to the x is an exponential. Don't get that confused with x squared. They look the same, don't they? Pretty close, but they're not. Okay, Natalie? 2 to the x is an exponential, looks like this. X squared looks like this. This is a power. In particular, it's a polynomial. So be careful with that. So you're going to have to realize where the exponent is. If the exponent is the variable, you're talking about an exponential function. Has way different rules. This I use the power rule. This I have to use the rule I haven't shown you yet. What if it's 2 to the x? So that's what we did in the other class. We actually made them numbers. And we did, or 3 to the x. 3 to the x, x cubed. You see the difference between the two of them? Exponential power. Okay? So, we're going to do method 1, and there's a lot of typos on yours, and there's still typos on mine. I guess I did this. First off, you have a to the ln of x, or x to the ln of x. It should have been e to the ln of x. Now, do you remember that property? E to the ln of x is just x. And then I still have this type, because that's the same thing. What's e to the ln of f of x? It's f of x. So let's do 2 to the x. Now, I don't feel very intuitive about this. When I look at that, I go, okay, it doesn't feel comfortable to me. I don't think that's going to help. Can I write on here? No. Let's add a page. So if I have e to the natural log of 9, that's equal to what? 9. Have you ever put it on your calculator? Because I honestly didn't feel comfortable believing it. I mean, I know these are inverse operations, but it doesn't feel intuitive to me. So if I have y equals 2 to the x, I want to write it as e, because I know the derivative of e. So 2 to the x is equal to e to the log of 2 to the x. You believe that? Properties of logs. I am waiting. These cancel each other out, right?
Wait, so what happens from the ln of 9 and 9 to y equal that?
This is just an example. So if I want to take y equals 2 to the x and write it as e to something, it's e to the log of 2 to the x. Remember that e to the log of some function of x is equal to f of x. These are the same things. I will. And you remember this? The log of a to the r is equal r times the log of a. Remember how you can do that? So, my y is equal to 2 to the x, but it's this. It's e to the log of 2 to the x. Grant says, why don't you pull the 2 down in front of the log? I said, that's a great idea. I'm sorry, the x in front of you. You said it right, I said it wrong. X times the log of 2. Now, the log of 2 is just some number. Just a decimal. Can we take the derivative of this? How about taking the derivatives? What's y prime? It's e to this thing back times the derivative of this. Now, that's just a number. It's just a constant. It's 0.691 something. I don't know. I don't have to use the product rule. What is the derivative of a number times x? It's just the number. So it's times the natural log of 2. Now we're almost done. We're going to back this up because I don't want the e there. Now we know e to x times the log of 2, that's this. That's equal to this, right? Going backwards. E to x log 2, Grant, is e to the log of 2 to the x, right? And that is the same as what? 2 to the x. You don't like it. What do you think if y equals, I'll show you another method which you'll be much happier with. What if y equals 3 to the x? What's y prime? This is 3 to the x. Remember what y was here. Y was just 2 to the x. So it's an exponential function. I get the same exponential function back again times what? ln of 3. So when I do y equals e to the x, because I like this to be consistent, it is, y prime is equal to e to the x times the natural log of e. What's the natural log of e? 1. Pardon? So in general, what is it? If you have y equals some constant to the x power, then y prime is going to be the same exponential function back again times the log of the base, ln of a. We're always doing natural logs. Everything will always be changed to natural logs. Adam. Why does it turn out to be e itself? Let's see, I'm trying to figure out how I did that. Because we did e to the x on that limit.
But in all of math, why is it?
That's why it's called a natural log.
There is no explanation.
It is. It is. You'll have to look it up. It's been a while since I've done that. Now, by the way, my first name is Lena. So I can remember this derivative because it's a to the x, and it's Lena, natural log of a, ln a, without the other a. But it still kind of just rolls off the tongue. But you will remember it now, right? Okay, what's the problem in here that we have? Did they give us one? No. So what if I had a to the, it's this thing back times Lena. Okay, so what if I have y equal 5 to the x squared plus x? What's y prime? Let's give you an example. 5 to the x squared plus x times the log of the base, remember? So natural log of 5.
What happened when we just learned like 5 years ago?
That's e. E has the natural log of e as well, too.
That's so much.
Well, e is the log of e, but what's log of e?
No, I know, but oh yeah, oh yeah.
Log of e is 1. You can write it, it doesn't matter.
And that's times
2x plus 1.
Oh, I got it. Because it is the same thing except for the log.
So if I have y equals e to the x squared plus x, no, that's a 5. This is e to the x squared plus x times the log of the base, log of e, times 2x plus 1. What's the log of e? But I like to be consistent.
Yeah,
Okay.
yeah, Cole's right. Cole's right. It's the exponent, look at it, it's 5 to the x squared plus x.
Oh, I copied that wrong. Here. Sorry. Okay. Now, we are going to skip method 2 for a second because I need the part that's down below about what's the derivative of the log of x to do that. I need to fix the handout. This is fixed. So skip down to the bottom of the page, and we're going to do the derivative of y equals log of x. Now, let's do it a little different in my other class. Let's graph that.
What happened to this?
Let's graph it. See if you can guess what it is before we do it. It's at the bottom of page 3. Okay, you guys, do you remember what log looks like? Now, on the calculator, it looks like it touches the axis, but it doesn't. Now, this is at where? Not 1, 0. Sorry. I always do that. Okay. Let's look at the derivative of this. Let's just look at it graphically. When you're here, close to the y-axis, it's very large. It's infinitely large, so it's up here someplace. And then what's going to happen to your slope? It's getting what? It's getting smaller. Is it still positive? Yes. It's still positive. Does it ever get negative? No, it actually has a horizontal asymptote of 0. Anybody know what that one is? It's 1 over x. Well, let's see that it really is 1 over x. Now, to do this, because I don't know what the derivative of the log function is, instead I'll rewrite this as an exponential. So what's x equal to? E to the y equals x. Or, if you want to do it this way, exponentiate each side. I don't know if that's a word, but we'll do e to this side equals, I'm sorry, it's an x, e to this side. So e to the y equals, what's e to the natural log of x? X. Okay, now let's take the derivative with respect to x. I show you this in case you forget, but you're going to have to memorize these. Okay, what's the derivative of x? 1 equals the derivative with respect to x of e to the y is e to the y. Chain rule times the derivative of y prime or dy dx, whichever you prefer. Does that make sense? That's right, but does this line make sense? Don't forget the chain rule, because you're taking it with respect to x, not y. I rewrote this log as the exponential. It's inverse. Solve for x. X is e to the y. What I did is I took e to both sides. Otherwise, I'd use the definition, e to the y equals x. Okay? So now, doesn't matter, dy dx is equal to 1 over e to the y. I have forgotten what y was. What was y? Y was the natural log of x, right? Let's go ahead and put that back in there because we can. So dy dx is equal to 1 over e to the y, but that's the natural log of x. What is that? 1 over x. Y is the natural log of x, and it's e to the natural log of x, but that's just x. So right now we have this. The derivative of e to the x is e to the x. The derivative of a to the x. Grant, what's a to the x? It's a to the x times the natural log of a. And then I want natural log of x. We still have to do a base other than that, but now let's go back to that a to the x one, and let me show you a different way to do it. E to the log of x is x. I substituted y because we knew y was ln of x, right? Remember where we started? That was my goal, to find the derivative of the natural log. Is that okay? I got one okay. How about the rest of you? Is that okay? Okay. Now, let's do 2 to the x. Okay. You guys, instead of rewriting as 2 to the x as e to the log of whatever, that doesn't feel very natural to me. So what I'm going to do is take the natural log of both sides, and I get the natural log of y is equal to the natural log of 2 to the x. What can I do to simplify the right side? What can I do with that exponent? No. Bring it out in front. Remember, what's true about the log of 2? It's simply a number. It's a number. Constant. Now let's take the derivative. No. What's the derivative of the natural log of y? With respect to x, though. Do the chain rule. What's the derivative of the log function? It's 1 over whatever's in there times the derivative of whatever's in there. So that's dy dx. Is that a problem? What's the derivative of the log function? The derivative with respect to x of the log of x is 1 over x. The derivative with respect to y of the log of y is 1 over y times the derivative of y with respect to y, but that's just 1. So what's the derivative with respect to x of the log of y? It's 1 over whatever's in there, that's f of x, times the derivative of whatever's in there. Okay? It's implicit differentiation. Remember that? And what's the right-hand side? It's just this number times x. So what's the right-hand side? Just the number, ln of 2. Solving for dy dx, that's y times the log of 2. Now I forgot what y was. We'll go back and look. What was y? Y was 2 to the x. There it is. You can think of it either way. I prefer this way. So it's 2 to the x times the natural log of 2. That's the derivative of a to the x. Hang on. Okay. Let me know when I need to erase. Sometimes I forget. You're not going to do the derivations unless you get desperate. You're going to memorize these. We just have one more to do, though. What if it's not base e log? Well, I only know base e, right? So why don't I do a change of base? Do you remember the change of base?
Where's that problem?
It should be there. Oh, look. It is on the bottom of the third page. Do you remember that if I have log base a of x, that can be written as, if I want to change it to base b, it's base b of the argument divided by log base b of the base of the original one. Do you remember change of base? Now, that's not proving to you why it works. I never did it that way. But I want to go to natural log because I don't know the derivative of any log but a natural log. Because what's the derivative of the natural log? Is 1 over x. E to the x is the only one that it's itself back again. Okay, so I want to change this to natural log. So y is equal to the natural log of the argument, which is x, divided by the natural log of the base. But remember, this is just a number. It's a constant. So when I do the derivative of this, I'm going to ignore the fact that this 1 over the log of a is there. In fact, let's even write it this way. I don't know if this is going to bother you or not, but this is the same as this. It's just a number. Log of 2, log of 3, I don't know what it is. It's just some number. Is that okay to write it like that? Okay. So y prime, remember we ignore the constant that's in front. We just write it down. What's the derivative of the log of x? Right up there. 1 over x. That's all it is. Now, I don't memorize the derivative of the log of x. I don't memorize that. I just change the base and take the derivative. It's usually a lot easier. They can be kind of complicated if you don't. So I'm going to go back to that page where I have all my logs, all my derivatives together. Was that this one? Nope. This one. And let's just add that in here. And this is the derivative with respect to x of a log base a of x. It's 1 over x, just like a regular log, times 1 over the natural log of the base. Do you see the similarities? I just want to make it easy for you to memorize. This is times the log of e. Now it looks e to the x, a to the x. It's the same, times the natural log of the base, natural log of v. But what is the natural log of v? So we don't write it, but it's there. And the same thing here. This is times 1 over the natural log of the base. What's the base here? E. But that's just 1. Do you see the patterns? I'm looking for patterns. It's exactly the same thing. These are the same, isn't it? 1 over x, 1 over x. It's 1 over log of the base. That happened to be e, which simplifies. I can't get rid of the log of 2. Well, I can if I want to write the decimal. It's not a nice number like e. So those are your derivatives. There's only 4 little derivatives. E to the x is easy. A to the x, you use my name, times the log of a. And then the natural log, I have to remember it's 1 over x. You could always sketch a graph and say, oh yeah, it's 1 over x. And you could always do that. They will have to do the chain rule. So let's do a problem. Are you ready? Now, the other thing you want to think about when you do these problems is to use your, I don't have it on here. Do I have it on here? No. Is to use your properties of logs. So let's review properties of logs too while we're at it. Properties of logs. So I have log base A of A. What's that equal to? 1. What's log base A of 1? 0. What's log of A times B? Remember that one? You do? Log of A divided by B is the log of A minus the log of B. I'll give you a couple examples. We'll do the ones on the sheet, and I'll give you one that was an AP question, or similar to one. I'm not sure if it was exactly the same, and how we can make it so much easier. And then we'll do a problem out of the homework. And the log of x to the r is what? R log of x. You guys in the back? And then we have e to the natural log of x is x. And e to the natural log of f of x is f of x. I think I've got them all. I hope. We are. So let's do this problem. Now, remember, this is in a smart notebook, and I put the smart notebooks up online. And you can download the software from smarttech.com. It's free. It's a tiny little file. It's a student version of it, and allows you to read them. You can even move things around. You just won't save it. That's all. It's kind of nice, though. To get used to having smart software, it's very nice. So here's an AP question. It asks you for the derivative of this function. I want the derivative. Find y prime. Now, you can do this. How would you do it if you didn't simplify it? Well, y prime is 1 over whatever's in there, which is this thing. And then what would you have to do? Chain rule times the derivative of the inside function. And what rule would you have to do this one? Quotient. Looks messy, doesn't it? Or is there an easier way to do this? If I use properties of logs, this is equal to what? Log of x, right? Minus the log of x minus 1. Tell me what the derivative of the blue one is. It's the same thing, by the way. I just don't want to get there. What's the derivative of this? 1 over x. What's the derivative of this one? 1 over x minus 1. So it's easy. If you use properties of logs, it makes your life a lot easier. One thing I forgot to do was back here, it says graph ln of x, which we did. You gotta go back and find it back here. What's the domain? I just forgot to talk about the domain here. Yes, the domain is x is greater than 0. By the way, that was a 3-point question, that derivative of the log of x over x minus 1. That wasn't hard. You evaluated at 2 or something like that. No, and that was the only calculus in the problem. The rest of it was all pre-calc in that particular problem. So let's go back to the end here. Let's do the problem that I have written there, which was, I don't know why it's not on here. Example 4. So if you have logs or exponentials, try to simplify them before you do anything. Now, I could do the derivative of that and do a change of base. It's way easier than that. What's the log of a to the sine of x? Yeah. But you see why you want to simplify? Because otherwise I'm going to be stuck with it, and we can write it out if you want. It's going to be complicated. So what? But this is easy. Y prime is what? Sine of x. That's it.
Log base A and log
If these match, then it's just this. Because remember, you can push this out in front. Because this is this, sine of x.
log base A is A.
Yeah. So, but if you don't simplify, then things are difficult. It'll work. Let's do 17. And you're assigned the odds. If you need to do more, please do more. Y equals the log of 1 over x. And you don't have time to start the assignment. It actually goes pretty fast. I mean, no. I mean, they're not bad if you get to 7 where you have to use the product rule. Don't forget the product rule. So if I do this as written, it's 1 over x times the derivative of 1 over x. Well, that's x times the derivative of that. Or, if I'm clever, this is the log of 1 minus the log of x. What's the log of 1? It's this one minus that one, right? What's the log of 1? It's 0. Log of 1 is 0. So what's y prime then? What's the derivative of this? Negative 1 over x. Yes. Log of 1 is 0. Log base A of A is 0. 1, sorry. Log base A of 1 is 0. Way to figure it out if you forget is, say, let's call that x. A to the x equals 1. The only thing for that to work out would be 0. Now, just a little aside here. What is the log of 1/2? Well, it's the log of 1 minus the log of 2. But what's the log of 1? So the log of 1/2 is 0. What is the log of 1/3, Cole? It's the log of 1 minus the log of 3. So the log of 1/3 is what? Minus the log of 3. Notice anything interesting here? 1/2. 0 minus, sorry, log of 2. I goofed there. Log of 1/2 is negative log 2. Log of 1/3 is negative log 3. It's just the log of 3, but it's below the x-axis. It's kind of a cool relationship. Kind of nice, especially when we get to population growth, to recognize all those same things. Just a little aside. Some of you may be not seeing that from before. Are there questions on homework from yesterday's homework? We can do problems together for the remainder of the hour out of 3-9, or I can let you work. Which is it you want to do? Work? But you should use it. I know some of you have a big physics test today.
I did.
Was it okay? Yes. Go back where? You want the properties? Pass it over there. I don't want that, I want this.